invite questions at this moment, and before we go into the actual details of the API from here on in. If anybody has it, or if there's anything on the Twitter feed, hashtag WebRTC.
So I want to come back to your slide of comparisons against CORTC Web, and I understand, like, how is this? In what way is it higher level than CORTC Web, and simultaneously being lower level than the current?
I would describe the RP API as really lower level than the current API. It's just that you don't manipulate it. It's more of a knobs and dials kind of thing, as opposed to writing everything into a descriptive language that then gets interpreted by an engine. So it's a way you control it rather than being at a different layer, so to speak. Whereas CORTC was more about controlling, you could actually control some of the way the ICE negotiation works. Now, correct me if I'm wrong, it's been a little while since you might want to speak more on CORTC Web than myself. But.
So the real-time transport object was very complicated in CORTC Web for a variety of reasons that we can all guess at why. But I think the majority of things that like having a real-time port and that sort of thing, like, it seems very similar to the concepts that are here in ORTC.
No, it's not. I would say that our model is more on the pure connection model than it is on the CORTC Web. Now, we were inspired by the fact that you could do an object model from CORTC Web, but it was not based on CORTC Web. We didn't actually look at the implementation when we were implementing our own version.
So is there a single pure connection type master object?
Yes, that's one slide back, I believe.
Too far. One slide forward.
Whoa. Back up. Okay. So RTC connection, that's your equivalent to your pure connection object. So same kind of concept.
Can you have multiple connections that are contained within a said RTC connection?
No, you would have one connection on an RTC connection only. So it's RTC connection represents one peer talking to another peer and negotiating its ICE candidates between those two peers.
Right, but the point I'm trying to get to is that in an RTC peer connection, you can have multiple transports, multiple independent things that would be carrying media.
Oh yeah.
So is that still the case for RTC connection?
Yes, absolutely. You can have multiple streams, you can have multiple tracks within those streams. You can have data channels. You can do everything the same kind of model.
Is it a single 5 tuple or not? I guess is what I'm saying.
Sorry.
Is it a single 5 tuple or not?
I think it's open here.
Is there a one-to-one relationship between an RTC pure connection and a pure connection?
No, there's not.
Okay.
This is a single 5-tuple.
Oh, okay.
Right, so this is a fundamental difference, and I guess it's more in line with CORTC Web than with pure connection. That you would have, multiple, in a single call where you use audio and video over different transports, you have 2 RTC connections as opposed to 1 pure connection.
Why would you have 2?
Correct. If you want to
Because they're separate files.
Oh yes, except for 5 tuples. Yes. Yeah.
So I think that's a fundamental difference that I think, in terms of understanding what levels is at, this is at a lower level because there is no analog of the RTC pure connection object.
Yeah, I mean, it depends on your perspective. I don't know. It's hard to describe. Exact differences. There's lots of different differences, right? They're not really comparable. It's just in some ways they are, in some ways they aren't. But CORTC Web is also very different too. So it's a different level.
Maybe this is going to become clear in a minute, but at least in
sorry, we have to use that.
Yeah, maybe I should let you going. This is become clear, but I'll wait for the but in a conventional, like in a call with the current system, and in fact in any call as far as I can tell, there are multiple 5 tuples mapped onto the same DTLS context because during ICE negotiation you flip flop between different 5 tuples, right? And those all go over the same. Each one of the DTLS connections are multiple 5 tuples. So which does this correspond to, a 5 tuple or a string?
So this corresponds more. You're talking about the ICE thing where you might go.
An ICE string corresponds to like order 25 5 tuples.
Right. Yeah, but this is one single ICE component.
Yeah.
Or
it's component.
Component.
Oh, awesome. Thank you.
Right. Well, is it an RTP session or is it component? As component. Move. Okay.
Yeah, so we'll get into a lot of these details.
Sorry, I'm having a little hard hearing. engineering, so forgive me for that. Okay. Any other questions that don't have to do with tuples at the moment? We can get into those details in a minute. Okay, just to reframe here, in the simple scenario, it's not different than you're used to in the peer connection. Now, there are going to be some differences to your peer connection. I'm not saying that they're one-for-one identical, but the concept here is that an RTC connection represents a single peer context to another peer's context when it comes to the tuple negotiation, for those who are asking. But we can flip to the next slide. When it comes to the object, when it comes to the object relationships, I'm not really going to go into details into this because I think that just confuse people. But I just wanted to put the slide up so that people can go back to it later and say, oh, what are the object relationships? The concept here is that everything kind of goes through this RTC connection. It is kind of a master controller when it comes to all of these things. Bless you.
Thank you.
And you have your ICE connection info, you have your DTLS fingerprint info, you have a whole bunch of RTC streams and stream tracks associated with the connection, which are in turn connected to their media stream and media stream track references as well. You have local ICE candidates and you have remote ICE candidates, and you have an RTC socket object, which is a conceptual physical socket on the wire, which also has a relayed component to it. So I wasn't really going to talk on this slide. I just wanted to say this is what the, for a slide, for reference later, this is what the current implementation looked like. It is a work in progress. As we get input, this will change. And as we start to implement and we discover any issues, this is going to change as well.
So does connect, I assume connect like starts the ICE negotiation, starts the ICE handshake?
I'm going to talk about all that.
Okay, good.
Presentation. I'll talk about all
I'm
that.
just wondering how you're going to group together, how you're going to
Yeah. I'll talk all about it.
Okay.
I'll get there. So I wanted to talk about the responsibilities of what RTC connection does. You have one RTC socket connected to an RTC connection. And the concept here is that a socket is a conceptual thing, and you can actually attach the same socket to two different RTC connections. So that allows you to transport the same media in two different connections going to two different peers over the same physical socket, which you might need in a forking to support a forking scenario. Not that we're necessarily thinking people are going to do that, but it is a possibility. It goes through the negotiation goes through different states when it comes to the RTC connection. When you first boot up the object, it starts in a new state. Then it goes through a searching state, which is basically testing the candidate connectivity between one local pair and one remote pair. Halted means it has not found a single connection that actually works. It needs more candidates to continue searching. And connected means it's actually found a candidate pairing that actually works, and therefore your DTLS and everything is ready to go. And then closed means the socket, the RTC connection is disposed of and no longer useful because you've shut it down. Okay. Next. RTC connection has a suggested role. It's just similar to the ICE connection, which is controlling versus control. It's just a hint to prevent unneeded back and forth packets, to change the role when it comes to ICE. You have local ICE credentials and remote ICE credentials that are part of the RTC connection, so that you can say your username frag and your ICE password. You have your DCL's fingerprint, which represents your local fingerprint, and after negotiation you got a connection, therefore you will have the remote fingerprint to examine. And you obviously have your ICE candidates, which are your local candidates and your remote candidates. And they're used for the connectivity checks. RTC connection is responsible for gathering the ICE candidates. So when you start the RTC connection up, it will start the gathering process when you tell it to. And it will also perform the ICE connectivity checks when it goes into the searching state, which you can tell it go in the searching state. You can specify with the RTC connection which streams and stream tracks media stream tracks are going to be going over the RTC connection and the mapping information over the nominated ICE candidates. Next. So
on all this, you go through, you sort of hint a little bit of like, which parts of this you think you can do as a shim and which parts of this you don't think you can do as a shim? Or
I
just
didn't really,
later.
I think we're going to have to, for me to answer that, we've implemented a test shim right now using an older version of our specification. It did work. There was some glitches because of the way SDP works, and it couldn't work perfectly 100%. But we did a lot of tricks to work around it. But I'm really not going to be able to answer that in this session because we haven't validated the new API when it comes to the shim yet. Okay.
Yeah, I think it's fair to say both the shim and the Node.js aren't up to date with this spec.
Yeah.
So
Because the spec is moving faster than the shim implementation has. We only have so many resources. And that's why we're also inviting people to participate to help us get this going. That's part of this process. So again, the RTC connection is responsible for saying, you can say which media streams and which media stream tracks go over this connection because it represents a single point to a single point. You can also see, you have RTC stream and RTC, which is a collection of RTC tracks, and RTC track represents the mapping when it comes to the on-the-wire physical RTP constructs. And it's a one-for-one pairing between an RTC track and an RTC, and a media stream track. Too many terms going on in my head. Okay, but it represents RTC track and RTC stream represent the on-the-wire mapping of what's happening in the RTP layer. Okay, RTC connection has a connect method. So when you first construct the object, it starts in the new state. And when you call the connect method, that's when it's going to start gathering the ICE candidates. There's a way to start that early, but I'll talk about that in a moment. Before you call the connect method, you must have your remote username, frag, and password for the ICE credentials. And
Sorry, I'm confused. I thought you said you're gathering your candidates.
yes, we will, but just give me a minute on that.
Okay.
Yeah, sorry. You're gathering your candidates at that time, the moment you call connect, but there's a way to gather candidates early. So there's actually a method to start the candidate gathering process earlier. Okay. When you call connect, it'll actually start the candidate search. So the moment you feed in remote candidates and you have local candidates, it'll immediately start the search. And when it exhausts all the capabilities, it goes to the defaulted state. Okay, next. So this is what you were asking about. We have a gather method that actually allows you to, before you call connect, because you don't necessarily, you might want to have your gathering process separate from your testing process. So when the object is in the new state, you can call gather to bootstrap to say, okay, start gathering your candidates immediately. And if you don't, just call connect, it'll automatically implicitly call gather because the candidates must be gathered in order to be able to connect. But this does not affect the state of the object itself, so it allows you to gather candidates before you test connectivity. Okay, next. There's a send method which you can pass in a media stream track by itself. If you send in a media stream, it's going to try and send all of your tracks contained within that media stream, and it returns to you an RTC stream and an RTC track which represents the mapping. So if you don't really care how the mapping works, you just want to get information about the mapping, you can just pass in the streams, it'll return to you the information. Or you can construct, which I'll talk about a little bit later, RTC stream and RTC stream track based upon a medium stream or a media stream track before you call the send method and therefore get all the mapping information in advance. And basically, it's a convenience method if you just want to call it with the media stream and the media stream track. And that's all I want to say on that. There's a receive method. The receive method, you can't have a media stream or a media stream track yet because you don't, allows you to describe what the stream will look like to the engine. So you construct an RTC stream or you construct an RTC track object, and those represent the mapping information. So you can give all the description of all the mapping to the engine in advance using the receive method, and it will in turn return to you the media stream and the media stream track objects constructed, ready to go for you. Okay. And obviously we need a close method to be able to say, shut it down, we're done. Okay, there's really not much more to say on the close. And it goes to the closed state. Next. We have some events, and keep in mind that this is an ongoing work in progress. On candidate fires when you have discovered a local candidate, and the candidate says we've exhausted all the local and relay candidates discovery at that moment in time. If you discover a, well, I'll talk about that in a minute. On an active candidate is if as ICE negotiates, it might start off on a non-optimal route and then switch to a more optimal route. So you can always know which local and remote candidate pairing is going on at any moment in time. And that event will fire telling you what's going on. On state change, basically as you're going through the new searching, halted, connected, and closed state. On network change, if the ORTC level discovers a network topology change, it'll fire an event saying that it's changed, and it's up to you to call the gather method again, which will fire on candidates again for any new candidates, and on end of candidates when it's exhausted all the candidates. And unknown track will fire when you have a track that comes in which has no direct mapping information, and it's presumed that there's going to be, depending on what we see come out of the IETF, what kind of RTP kind of extensions that give you the RTP mapping information on that layer, and therefore we'll fire that. So that might change depending upon what we see come out of the IETF. We have a concept of RTC socket, and you notice that the implementation interface that you have to use is really, really simple. There's nothing in there, and that's kind of intentional. This is also open for debate, like any other part of the API rather. But the concept here is it gives you a physical socket that also has relay potential, and it can discover any stun candidates for that socket as part of the gathering process, and you attach one of these sockets to your connection. And the reason why you have a separate socket object from the connection object is because it allows you to reuse the socket in other connections. So if you want to have multiple RTC connections attached to the same socket, it's easy to do so. You just create one of these guys, you pass it into multiple RTC connections, and you're guaranteed to reuse the same socket on the wire when it comes to what's going on.
So, back to the 5 again. No. Now we have two RTC connections that share the same socket.
Yeah.
And what's the envisioned use for that?
Well, there are alternative protocols out there, for example, and there are SIP that can offer forking scenarios. That's one scenario where it might be useful. So in that scenario, you might present an offer out there saying, I'm at this socket, and get back multiple answers. And so without having to re-update the session to say you need a new socket to communicate, you can just reuse the same socket by taking that socket object you have in one connection and forking it to the new one.
So this is like cloning.
Pardon?
This is similar to the use case for cloning of your connection.
Sorry,
Yes.
cloning. Yeah, it is, but you don't need to actually clone the object in order to do so. It's not necessary. But that's not the only use case. There are reasons why you might want to not use a lot of sockets, in the sense that you don't want to open up a lot of sockets locally or through your firewall or whatever have you. Just want to keep the sockets locally. There's use cases like that. And I can't even begin to imagine all these cases, but I know that there is certainly the forking scenario where you need to do that.
So how do I instantiate a socket? Like just a new RTC socket?
Yeah, it's just
So
a new one.
what binds it? Okay, so in a classic ICE setup, right, you can bind one to every network interface.
Yeah, so when you create an RTC connection, you need to either pass in one of these, and if you don't, it'll create one for you.
So what does it correspond to, is my question?
A physical socket on the local internet.
Right, but the sockets can be bound to one address, not multiple addresses. In this case.
Well, it would be bound to all your local interfaces.
That doesn't always really work that well.
Yeah, it doesn't work.
I mean, internally, you definitely can't do that operating system level. Internally, it has to get different.
So you're assuming that they're just doing open UDP?
He just told me it was one socket.
No, you said it was
Conceptual socket,
conceptual.
whether it has to be physically separate sockets together or independent, it doesn't matter. It's just conceptually one local port, depending on how you have to support it on the native OSs. I know for us, we bind to the when we implemented this socket concept, we bound to every single interface independently, as opposed to binding it to zero address.
Right, you have to do that.
Well, you have to in order to be able to detect all the different traversal scenarios.
Yes.
Yeah, I'm aware of that.
Okay, so this corresponds. So yeah, that's right. This corresponds, and the application, the underlying operating system, when I request for the browser, when I request this, will then enumerate every single interface and bind each one of those.
Yeah, absolutely.
So this encapsulates more like an ICE endpoint rather than a socket per se.
Yeah, it's kind of hard to describe because we don't have really a term for it. So if someone has, I've debated on this one myself a lot, what to call it, because anything we came out with even more confusion and less confusing. But so we came up with this name. Is it the best name to describe what it is? Not really, but it's open for debate, and if anybody can find something better, propose it, by all means. I'm not married to this concept of what it's called, or any of those concepts.
You can map one among the RTC, the endpoint, and ICE endpoint is called RTC ICE endpoint. If it does the same
long
thing.
as it's known that exists, except for the fact that it doesn't exist.
I invented this.
So thank you, Justin.
Yeah,
It's open for debate.
Are used for ICE.
Yeah.
Is what it is like referring to.
Yeah, it's open for debate. I mean, I really, I'm not an expert when it comes to naming things. I'm a developer, not an English professor, so it shows.
So, look, I don't know if you have other slides on this or something, but I'm really interested in not so much how the transport gets set up, the ICE stuff, I think that's important. I'm also really interested in how the sort of negotiation setup of all the parameters steps on the other sort of.
Sure, yeah. We're going to be, some of those things are a little bit light because
I understand it's work in progress.
it's a work in progress, but I just we wanted to cover the high level things first and then go into a little bit details later. So we'll probably have to come back to some of those slides perhaps to be able to present some of that information. Okay. RTC socket, no members. I think I already talked about this, so we can skip on to the next one. RTC stream. What is RTC stream? It's the representation of a media stream object. It's connected to the media stream object, and it's the container of all the RTC track objects. And I'm not so certain about these methods or something like that, so take all of these with a little bit of a grain of salt, as this again is a work in progress. But the concept here is that you have one RTC stream object. Why do we have RTC track up there? There's a mistake on this slide. Let's just say RTC stream, not RTC track. Anyway, there's a mistake there. Anyway, so it's basically the collection of RTC tracks, and RTC tracks are the more important thing to talk about anyway, so we can switch to the next one.
So real quick, that was RTC stream, not RTC track.
Yeah, there was a mistake on the slide. I don't know how that happened. Copy and paste something. I don't know. Again, RTC stream points to one media stream object. It is a collection of RTC track objects, which are the mappings to the on the RTP of each media stream track. It's an easy way to have a collection and just be able to say send it, or a collection be able to receive it for marshalling purposes. And it just, basically it's all about simplifying the usage for RTC connection. And it has, I'm still in debate about these two last points, but it has a convenient method to start and stop the actual transmission of the stream on the wire when it comes to the media streams going over a particular peer connection, but that's open for debate. Next. RTC track object. This is where you have the construct of the mapping for the wire. So an RTC track object contains all the information needed, and this is obviously open for debate as we see movement in the ITF and as people have come up with different use cases, but it has the basic things that you might want to have in here, which is your SSRC mapping, your codec list involvement for each track, your extended media stream attributes that are going to be in this object. There's a lot of debate, obviously, on what things need, especially when we're talking about different video codecs that are coming down the pipe. And so I didn't really want to focus too much on a lot of the great details here, because I think it's really important we have the basic constructs, and then each individual codec or codec parameters and media attributes. We add media attributes as we find the need for them and describe them appropriately to do the negotiation.
So Raymond, on this one, I'm interested, like back to the very beginning of your object diagrams at the beginning of how this is just, controlled directly. I mean, so sequences like, you don't have to go back, it's fine, just understand. So if we start talking about codecs, I mean, how do you get those? Is that something you can set, or is that something you can only read? I mean, is that a read-only?
No, there's a way to get the list of codecs out of the browser, and that's one area we have to work on still. There's a capabilities. We just removed that section because it was really weak sauce as far as I'm concerned.
Right.
And we wanted to be able to get the list of codecs that are capabilities out of the browser. And it's going to be more of a IANA kind of perspective where each codec registers what it is under a name. And based upon the name, you would agree upon what attributes that codec would definitely support.
But that seems you're going to be back to the type of model you were trying to avoid, where you have to get something from the browser, it's called capabilities, manipulate some stuff in the JavaScript, and then push it back down, right? Which was the model that seemed to be being tried to avoid.
With that, because it's capabilities, there's nothing stopping you from having objects within that model. So if you had a different codec, you can actually have models if it makes sense, or no models if it doesn't make sense, if it's a simple flat structure. So there's nothing stopping that. I think we have to wait and see what the codec people come up with and say that they need this, they don't need that, what actually is needed on the wire. You know as well as I do, there's a lot of debate over all of this, and I didn't even want to attempt to try and solve it.
There's debate about the minimum. There's no debate about what's needed. I mean, there's definitely people who name any codec, and people think that it should be fine to be able to use not any codec, but a wide range of codecs.
That's why I wanted to
negotiate all.
That's why I wanted to approach it from an IANA perspective, so that everybody who agrees to say that this namespace means this set of things, and that way we can get that discussion out of this API. Okay.
So just so I understand, when my browser adds VP9, what has to happen for application makes to that?
What has to happen?
So when Firefox adds VP9,
yeah.
What has to happen for an application to make use of that VP9?
You will have the capabilities of the codec there. It'll be listed as an IANA reference point, and if we would hope that it would be able to easily marshal those capabilities out in some way. We haven't discussed what that would be exactly, but if there is a marshaling perspective, you would do it, or you would, because it's IANA, because it's registered, you would know what it means based upon that codec description. Usually you have to have both parties know about it anyway. It's not something that you can just offer up and typically use unless both sides know about it. So you're either going to have to marshal the parameters as is and have the other side interpret it, or you're going to have to interpret it yourself and provide meaning and context to the other side. It also depends on the protocol you're using. So there's no real simple answer to that.
The reason I'm asking is because that's actually quite different from what we use in the current system, where basically, you add the minute Chrome or Firefox adds VP9, it just works. Every other browser supports VP9.
Yeah.
With no operation.
In theory.
Right.
In theory.
Well, I added Dull and it worked, so I'm sure you added that. That's going to work.
Yeah, that's fine in theory, and there's no reason why we couldn't do the same thing, because you can marshal out the capabilities based upon the different codecs and offer them on the wire. There's no reason we can't do the exact same thing. It'd be more of a JSON type construct, but it's all you need out of every codec is the set of parameters that you're going to be operating with. So as long as you have those set of parameters, it will work. So I don't see any difference anyway. But I think if it comes to something detailed like that, we should probably take it offline, and that way you can interject to say, well, have you thought about this? And we probably haven't. We should argue those points by all means. Where were we?
Back to Colin's point, though, it does sort of seem that we can fill in the RTP header extensions to fill in the codecs. You still need to obtain a blob of something from the browser and then stuff it down into.
You do, but it should be more of just the attributes you need, not a format to manipulate. So it should just be based on those attributes. And it could be object attributes that marshal too. In JavaScript, you can have, as I'm sure you're well aware, obviously, you can have a marshal aspect to it, so it can marshal out the default state if you don't understand what it is, and then have different object properties and methods to be able to manipulate that on an object level. So you can have a duality to the whole object if you want in the model. And that's what I would propose. But again, open for discussion, and let's discuss it.
So one thing here is it says the mapping of RTC track maps to SSRC, right?
Mhm.
So how does it handle this sum of cost layer for the business? There you have the same SSRC.
We've had a discussion of layered codecs. Some implementations have the same SSRCs, some have multiple SSRCs. Anyway, there's a discussion in the Barca community group about handling simulcast and layered codecs.
So nothing has been decided.
No, nothing's discussion. We're definitely looking for input in that area.
Yeah, part of the debate is exactly what model are we using, what things should be infinitely variable, what the layering and all that kind of stuff.
Yeah, it's because important for the same cost scenarios. There.
Yeah, absolutely. Yeah. What did I say? Nothing really important.
How do you, so let's say we've decided that H264 meant a specific profile with a certain set of parameters would be supported. Like, how do we interoperate that with SIP or something that actually supports not a wider degree, a wider range of things than the sort of IANA approach where you're just trying to pick a single point in a white space?
I'm not sure.
I understand we have a bunch of points, right? We have H264, profile 1, profile 5, and profile 22.
Yeah.
But we define in a new IANA registry what each one of those means. It means, okay, you've got these capabilities.
Yeah.
But when we want to map that over to an existing SDP endpoint,
That'll be the responsibility of the shim layer.
but what happens when the SDP endpoint chooses a parameter set that is not exactly the same as that IANA profile, or is that just not allowed, or it just doesn't work, or what happens?
I think we have to explore that particular scenario to decide what's going to happen, what the correct behavior is. Should it be an error condition, or should it be allowed within certain parameters? I don't know. I can't really answer that at this moment.
Yeah, in that particular case, given the complexity of H264, if there's a profile mismatch, you're going to pretty much have a lot of trouble.
Yeah.
But I mean, Polygon and Cisco stuff works very well together today in many cases with very different
I
sets
mean,
of
this
data.
is-
The
this
SDP
is-
set up to negotiate that, right?
Right. I mean, I think that's the responsibility of the shim as well as the provider to say what it means. That's why there's a lot of flexibility in how you interpret it. That's why it's an object model too, so that you can provide multiple interpretations, so you can make things work beyond what you expected or decide the logic of
The
the
object
object.
model is a syntax issue. That's how we represent the semantic information. But the question, I'm not worried about that. I never care about syntax. I'm great. I love the syntax to be in curly brackets today and neatly brackets tomorrow, whatever. Right? But at the semantic level, I'm just trying to get it through my head of how we map this point sort of view of how a codec was described with a much more parameter-based view.
I think it depends on how we're going to be approaching this. We're approaching this from a let's get down in the code there, let's get practical, let's actually try and implement these things and see what comes out of it, as opposed to let's have lots of discussions and figure it out. So I think it's just more of our approach scenario, and we're obviously going to be looking for input from people to discuss and say that's not going to work because if you thought about this scenario and such like that. But I think it's more of an approach than that. So that's the way I would answer that. I didn't really want to talk about this in great detail, but basically there's a whole bunch of helper objects, and we're going to define the details of those. But basically, they provide your ICE and DTLS information, fingerprinting, your ICE credentials. There's not really much to talk about here. Candidate information. We just stripped out one of those because it was silly. But it's your standard ICE candidate stuff. We'll probably be perhaps make this a little bit more object-based. Now, these are more of the references. I wanted to have a page in the slides that will point you to all the different pieces of information, define where your specification is, where the group is. We really want to invite everybody to come in and contribute and add their 2 cents in a productive way, obviously, and help us with implement the shims and our various different implementations when it comes to whether it's the mobility or the Node.js or the browser implementation, whatever you can offer, come on in and help us. We really need the help, really need the participation, and we're just at the early starting phases. So there's a lot of questions to learn there, and I don't think we really wanted to solve all the questions immediately. I don't think that was our goal. I think our goal was really, again, back to the practicality of it. Let's actually implement these things, get some reference implementations, see where things work well, where things don't, especially when we're talking about an object API. Usually APIs go through several series of revisions, and the only way you're really going to know if it works well is to actually try it. And I think that's what we're trying to do. And we encourage everybody to participate and get on so that we can really come up with something cool. And obviously, the main link you really want to know about is the community group, where we're going to post links to all the different sites. And there we go. And I think we're gonna go over the demo in a moment. We think we have some time for some questions right now. Sure. I know we've been asking along the way, so maybe there might not be any, but.
So I say that the assumption here is like all the RTCP is multiplex over RTP, right?
Yeah, all the RTC.
So and you said like you are addressing more than browsers and devices and all this. So what about those devices or endpoints that cannot do not want to multiplex RTCP or and RTP in this sample?
I think that there are two ways to approach that. One is we can extend the model to say the mapping object contains information, say I only want you to send the RTP over this and the RTCP over that. The other way to say is no, we're just simply not going to support that. There are so many changes already when it comes to DTLS support, when it comes to the ICE negotiation, and that we really aren't worried about that kind of backwards compatibility, and it's up to the legacy interop there to handle that. And one of the reasons why we can say we have the Node.js library, for instance, that allows you to take this and repackage it in another format, for example, on a server layer. So I don't know the correct answer. I'd say there's two answers, and I think that's open for debate as to which way we go. I didn't really want to pollute the object model to say, okay, let's introduce 2 sockets, right, and not 1, because then it gets,
I was thinking more like if I can create a socket for RTP and create a socket for RTCP.
Yeah, that's how we originally had it, actually. And then there's the additional complexity just really lived up to the benefits, I think. But again, I think it's open for discussion. There are different approaches like that too.
Yeah, I would like to say that I share this concern. I mean, this is basically really putting a restriction on the media layer.
Mm-hmm.
And also, if you strive for achieving compatibility with the current WebRTC API, and this is a feature that is possible with the current API to basically send RTCP and RTP on different ports.
Yeah.
So this is basically a restriction that you put in there, and that makes it incompatible in a way.
Yeah, no, I understand what you're saying. There's 2 aspects to that. One is, I would say that we're not aiming to be, whatever they do in the 1.0 API must therefore translate into the ORTC necessarily. There might be some features that we just are not going to support. Having said that, I too share your concern about being able to split out the RTCP from the RTP. I just don't know if we have to do it in the object model or we should do it in the mapping. And that's the debate point, I think, how we do it, rather than what we do. So it is certainly possible, but there's a lot of complexities that come out of that. For example, when you're talking about the candidates, you're not going to just fire one candidate into the object and be done. Now you're going to have to provide context to the candidates because it's in the context of this socket or the context of that socket. So if you do it in the object model, you have to be really careful on how you do it. So I don't know what the correct answer is. I would say that, again, join the community group, bring up this concern, and we'll absolutely discuss it amongst ourselves and try and figure out the best solution. Maybe some clever person will come up, well, this is how you can do it in an object model without making it so crazy and hairy to deal with.
We figured out how to deal with bundle negotiation.
If I were to
We figured out how to deal with bundle negotiation. So in the way bundle is supposed to work for compatibility with SIP, right, is that you have to offer distinct ports in the offer, and then they get coalesced after you decide their side will take it, right? So how do you do that here? Do you stop the RTC connection attribute? Like, how do you do that?
Sorry, I don't know.
So the way bundle works, right, is that in the offer, you're agnostic whether you're deciding to support bundles. You have to offer discrete ports and discrete ICE candidates for each component, right? And then when the answer comes back, you're like, oops, actually it's going the same quartet, right? And so how do you do it? So
Multiple connections.
no, I'm confused.
Multiple RTC connections.
No, I understand, but then you have to how do you tell it, oh, you're actually going the same transport?
Receive them on the other, receive the tracks that you were going You've told that the second connection that you want to receive a particular track, given it a particular description for that track or stream or whatever it is that you're trying to receive. Take that description up to the first one.
I think I'm going to need to restate that. So do it. You want to show me later?
So bunch of connections.
Let's just assume I have one audio, one video for simplicity, right?
All right. One audio, one video, one connection, another connection. Video signaling.
Yes.
So you've got to go out there with an offer that's prepared to receive some media. So you put a description in that says if you get some media in, I can render it now. One audio, one video.
Yes.
On the two connections.
Yes.
Get back an answer that said bundle, and you go, oh, okay, we'll just move that up there. You can actually put both descriptions. So say the audio was the first one that you wanted to be the bundle line. You put the description of the video line on both of those.
But I also need to reattach the MSTs to that first RTC connection, right? Yeah, I'll go with that. Right? Yeah. I'm just trying to figure out how this actually works.
Yeah. Sorry.
I'm sure it can be made in
But
one.
I'm having a hard time hearing the echo.
Yeah, but I'm sure it can be made in one. I'm just thinking how it does work.
I think the natural fit would be, they'll say, where the video, say video dot connection equals connection one, which was the original connection.
Sure. That's what I was expecting, actually.
Okay, whatever.
Yeah.
I haven't thought through all these myself.
Okay, at this point, if nobody has anything urgent to discuss, I would like to present the demo. Or I'm not going to be presenting. Microsoft Open Technologies will be presenting. Thank you.